So I'll just take this session. I'll take you through some of the tools that have been powered through AfricaGeoportal, which also exist throughout the entire ArcGIS system. So AfricaGeoportal, which I'm sure many of you are aware of by now, is a resource that was made available as a special initiative by Esri to ensure that there's access to geospatial tools, data, and learning resources for young professionals in Africa. So what I just want to cover is basically the capabilities we have that have been enabled through the GeoPortal as an initiative, and also that are generally available within the Esri framework. So my presentation will cover these main areas just to touch on, again, a bit about how we see AI, machine learning, and deep learning, especially how we embed these capabilities within ArcGIS. So ArcGIS is our main product as Esri, or our main system, which has different components that allow you to organize data, be able to analyze it, visualize it, and share it out for use by different people. And then we'll look at the tools and workflows that we enabled within ArcGIS, and I'll just demonstrate a bit of that based on 2 sections. Then finally, we'll just cover the resources before we go to discussions. So for those who are first learning about Esri, this is, as an organization, we've been there for over 50 years, if I'm not wrong, 53 maybe. And we serve a lot of users of geospatial technology. So this has grown to support different kinds of uses or workflows, depending on the area of expertise that some of our customers are in. So we have all those numbers of organizations, and this comes to about over 10 million individuals who are using our technology globally. So just see, like, the little dots on the map indicate where our presence is in terms of offices, but we also provide the additional support through a strong network of partners, as well as user communities that we engage with, such as DSN. So our main offering is ArcGIS, and this system allows us to support our customers in being able to access, manage, and make use of spatial data. So being able to do this, it just covers on different aspects of trying to make use of this information, whereby the first bit is to try and capture this information. So it will be measured by different devices. Then beyond that, once it has been organized, to try and visualize and identify what are the patterns and relationships between this data, which can also extend into analysis and modeling. Then we use this information to take actions. It could be in planning and design. It could be in decision making, whereby we're trying to find the best way to empower some of our stakeholders or leaders to make informed decisions based on the information that is there. So all of this generates action, which ideally is to help different users or different functions across the globe. So just delving into AI, so this is a capability, as I mentioned, that has been brought into our system. And again, our system, AfricaGeoportal, is part of our broader system. So here I'm engaging the audience of members of AfricaGeoportal and users of Esri technology. So all of you just fall in the broader framework of our users. So I believe the previous presenters touched a lot on this aspect of what is AI, machine learning, artificial intelligence. And this is how we basically view it, whereby our tools or our resources that have been enabled across board actually touch on the deep learning, which is an aspect of machine learning. So we've been able to put in tools and capabilities that would allow us to be able to come up with information or extract information or make useful insights from what can be handled within our system. So that could be images, could be text, a voice, and LiDAR. So when you're looking at aspects of point clouds or 3D elements, we also have the ability to handle that information within our system using deep learning capabilities. So ArcGIS, as a system, has many components. So these components allow you to do a bit of data collection. They allow you to map and visualize data, do a lot of analysis, which we'll look at, be able to integrate with other systems that are there. So you might find that we have our native system, but we also have other aspects that are outside our system. And we'd like to integrate either by bringing some of the aspects from that system, such as data, services, and so on, into the ArcGIS environment, or to push out spatial capabilities into those systems. So we also have found a way to enable this capability across board to allow us to do these different kinds of things. And all of these tools, again, I think we did a previous session last year, DSN, if I'm not wrong, and I had been able to cover some of these aspects. But yes, all of these tools does have different uses, and you can take advantage of them at any given time, also within AfricaGeoportal, to support some of the activities you're interested in. So for example, if you want to collect data, if you want to visualize it using smart mapping capabilities, if you want to create dashboards for decision making, providing situational awareness, then we have all those tools there. And again, when we're looking at machine learning integration, definitely, as we said, it's a cross-platform based on what you're interested in using. So we have specific products also that have these capabilities strongly embedded in them. So definitely for being able to use our environment for using Python scripts, that's available. We're working with real-time data or big data, that's available through a product known as ArcGIS Velocity. When working with notebooks, that is an environment that has been built on top of a Jupyter Notebook. Again, we have those capabilities in there. On our desktop application, that's ArcGIS Pro, we're able to use it. On our online platform, which is where AfricaGeoportal is, it's accessible, and so on. So we'll just look at what would be possible by this. So within ArcGIS, again, those capabilities that you saw have been embedded in different products. They enable us to do different things. So we are able to, first and foremost, extract information which could be pulled from imagery and LiDAR data, but also extracting insights from unstructured text. So these capabilities, again, being embedded across board, allow us to pick out information based on different criteria that you've placed in it. We're able to make predictions on data if we have multidimensional data. So this could be having an element of elevation as well as space. Then we can make predictions based on what has been historically collected, use our tools, and come up with an estimate of what the situation look like in future. Again, finding patterns and clusters. If we have data that has been collected and you're trying to see is there any influencing factor? And if it is, how is this information aggregating then? Machine learning would allow us to do that. To detect anomalies, in case there's an outlier of a situation, we want to pick that out and resolve it, then we will be able to do this. So for us to achieve this, we go through a standard life cycle. That means that generally, when you want to perform or if you want to conduct any kind of analysis or access of data using machine learning within ArcGIS, then we would anticipate that you go through these different steps. So the first one is you need to prepare your data. Maybe like if you had an image, you want to label your image and to come up with the information that you would use to actually run your models. After that, you train your model. In this case, based on the models that you brought in, or the libraries that you brought in, we can use that to train our model to go through our image, for instance, and be able to pick out the information we need. So once the model has been trained, we go through the process of inferencing, and that's actually doing the analysis. So that means depending on the number of times you feel that your tool would need to run to give you accurate results, then you conduct inferencing. And most of this is usually determined by the processing capabilities of your device or of your workstation. So if it's it meets the requirements to do this, then it will bring out this information within a shorter time. Again, if you're looking at a smaller area versus a bigger area, definitely to take a much shorter time when you're looking at a more smaller area compared to a larger area. So beyond that, you need to derive insights, not just running tools and getting results for the sake of it, but also being able to get useful information that can be acted upon when you share it out. So in ArcGIS, we have two ways that we can access machine learning. So in the first category, we are providing access to these processes or AI workflows in a codeless experience. So in this case, if we have people who are natively GIS professionals, we also have people who are data scientists with not much experience with using Python or scripting languages and so on, then we provide access to these capabilities through the standard tools we've always had. They have a desktop application which is powerful enough to run some of these tools, and those processes are enabled using extensions that we have. So you have a spatial analyst extension, which when you enable, you're able to run some of these tools, or these capabilities are activated. We have image analyst that focuses mainly on working with raster data or imagery, and 3D analyst if you're looking at working with LiDAR data or 3D data. So code first experience is for people who are very comfortable with scripting or who are developers natively. And you'll find that these are users who are external to the GIS system, and now we are geo-enabling them, meaning that you're giving them the capabilities to work with spatial data within the environment. So you're able to use things like notebooks, ArcGIS notebooks, and you can use our Python API to also bring in the relevant libraries that you need, capabilities that you need to work with spatial data. So the other aspect of how machine learning can be used in ArcGIS is AI-infused capabilities, whereby we have outputs or products that were generated through AI or have capabilities that are not specifically tied to the actual dealing with the data, but they support some of the work that you're doing. So for example, if we look at our data collection tool, that's Survey123, it has some of those capabilities which could be used to train and also help you to collect data in the field. So for example, if you're collecting specific plants and you've already trained your model to be able to identify that, for example, this is what cassava plant looks like or leaf looks like, then you will be able to use this capability that every time you take a photo of that particular plant, it can identify that this is cassava, and maybe this cassava has been attacked by this pest, or it has been attacked by this disease, and so on. And this is probably the rate of effect on this particular plant, and so on. So we have those two aspects of accessing machine learning. So the tools that we have in ArcGIS allow us to do 3 categories of things. And again, these are capabilities that keep on growing over time. So able to classify what is on display on your image or your data. You're able to create clusters, identify relationships between your data. This is especially good when it comes to space-time pattern mining, where you want to identify over time, where have we seen consistent outcomes, or where do we have an anomaly, and so on, which can help us identify the best time to take action. And finally, we're able to make predictions using some of those algorithms that all of you are very familiar with as data scientists. For me, I'm still new at this, but it's still an exciting thing. So the workflows that can be enabled by these tools that I've mentioned include being able to predict situations, as I mentioned, where we can see we're able to do a bit of forecasting just to assess what is likely to happen in future based on what has previously happened. Also able to identify clusters of information based on, again, what has been collected and analyzed through our algorithms. We can identify anomalies, especially in cases where we want to see what is an outlier in case we are monitoring different activities. This allows us to do that. Again, another capability that is mainly enabled using machine learning is being able to work with imagery. So we are able to manage our images, that is, bring them in, organize them, label our image just to help us with the training, create our training data, do the modeling repeatedly, finally getting results that can be used for deriving insights. And yeah, so this supports different kinds of imagery provided it's raster data. We are able to do that, and we just complement capabilities that tie to vector data. And the different tasks is that you're able to classify your image, you're able to detect objects, be it moving objects or being able to extract features within your image and so on. So all of these capabilities are within that. And just in case that you can see there's a lot of messages on chat. I think if there is any question about this being shared, yes, I'll share resources at the end of this, including the information on the slide. So another thing just to mention is that for those who are trying to do some of this analysis without actually creating a whole process to do it, you can take advantage of the pre-trained models that we have within Living Atlas. So Living Atlas is our collection of geographic information from Esri as well as partners to Esri and other global agencies. So if you're looking at the national statistics agencies, national mapping agencies, and so on, they have provided information, and Esri works with them to curate this information for use for different countries. Similar to this, also in AfricaGeoportal, we also work with these agencies to have country-specific portals that can be used to share this data and capabilities. So again, if you're looking at imagery, we are able to detect objects as well as classify the objects detected. So for example, if, as I said, we might want to identify where specific crops are and the crop health and so on. Also able to detect objects, such as you can see that you're able to track vehicles in full motion videos just to see where a particular object is moving and so on. So we're able to do all of that, or we have those capabilities within the system. And finally, if we work with, if we are working with LiDAR data, so that's point cloud data, it's possible to use these tools again, or sections of these tools, to be able to identify and classify some of this information for use. And the outcome of that, in case you check our Living Atlas, is kind of like the trip. Yeah, we have some of the data available already on the Living Atlas, such as 3 points that have been picked and shared there, as well as building footprints from some different sources. So for those who are not, or those who are interested in the code first experience, through ArcGIS Learn, you're able to bring in some of these capabilities into your environment. So you basically just need to call ArcGIS Learn, and you're able to access some of the different capabilities or libraries that you have, identify how many times you want to run this particular tool to get the results. So under ArcGIS Learn, we have the ability to track objects, pixel classification, prediction and classification, and so on. Basically, what I showed will be available on the codeless experience, is also available on the code first experience using ArcGIS Learn. And as I mentioned, if you have text that you would want to be, excuse me, that you'd want to be translated from or picked from documents and so on, we're also able to do that. So for example, if there are reports that have been collected over a long period that maybe has tables, this information is collected in tables, and you have the place name, you can actually use some of these tools or scripts to extract this information and actually map it, and then go further than that to do your analysis. Beyond that, under ArcGIS notebooks, you're able to also bring in some of the libraries that we have. So we also, within ArcGIS, you can access open libraries from numerous sources and also interchange your analysis or your work from our main interface onto other platforms and so on, and be able to continue with your analysis. So just to summarize, as a data scientist, you should be able to work with spatial data, access data that is the result of some of this analysis that I've mentioned, be able to visualize this information. So we have smart mapping capabilities on our map viewer that can quickly look at your data and identify the best way to display it and so on. Analysis is also enabled using deep learning. And finally, if we want to work across other systems and so on, then we have spatially enabled data frames that you can take advantage of. So if you want to, for example, read and write JS data across board, you'd be able to do that. Perform indexing on your data just to make it a bit more responsive in terms of trying to visualize as well as analyze it, then you should be able to do that. And again, we have cases where people have used these resources to do their different kind of analysis or visualization to make informed decisions and take action. So that's just an example of where this has successfully been done. And we continue to have different users taking advantage of these capabilities to support different functions or needs within their countries. I'll just stop my presentation there and switch to demonstrating those two scenarios. So we have the code-less experience as well as the code-first experience. So in the first experience, I would just like for us to look at what or how you can perform deep learning analysis, or how this has been enabled within our desktop application. So within the ArcGIS system, I would say that this is a very critical tool that is ArcGIS Pro, which is a desktop application that you can use to visualize your data. You can use to analyze your data and then share it out for use as a service. So it can be a map service, feature service, geoprocessing service for use across board. So the interface of ArcGIS Pro is very easy to get used to for those who've never used it. So it just uses ribbons, for instance, to organize the information and functions of what you're interested in. And also we have ribbons that are activated or are contextual based on the kind of data set you selected and so on. So we will use a scenario that's available here on trying to see how we can use deep learning to extract insights or extract information from our imagery. So in this case, in our area of interest here, we can see that there are actually trees, and we would like to use deep learning capabilities to extract the trees from this image. So to do that, I'll go through the process that I mentioned, that is preparing our data, then training our model, doing the inferencing, and then sharing out this information for you. So in the first case, if I'm interested in doing this, I could start first with labeling what in my image based on my understanding what are palm trees. So to do that, I will basically click on this imagery tab here on the ribbon and use my classification tool to label objects for deep learning. So once I do that, I can just be able to draw circles across different, some of the different palm trees that I can see on the image itself, just to be able to use it. So once that is done, I can export this as my training data. And again, you're also able to upload this information if you already have it, like you don't have to always generate all the time and so on. So beyond that, once that is done, I can use the geoprocessing tools that allow us to do analysis on our imagery. So as I mentioned, we have different extensions that would allow us to work with imagery, and this time I'll just focus on the image analyst tools. So we have tools that allow us to do different activities. As you saw, we are able to do change detection and also do different things with our data. So also, remember when we were saying about the space, time analysis and so on, we have these capabilities being embedded in here. So in my case, because I'm interested in deep learning, I can just use the tools within this toolbox to do this. So as I mentioned, the first thing I would like to do is export my training data for deep learning, then train my model, and finally detect objects. So I want to detect, based on the information that I have fed, what exactly are the palm trees and so on. So if I was able to collect all the different points for my indicating where my palm trees are during the labeling and so on, you can just see that has already been drawn. And after that, the first tool I would run, as I mentioned, was export training data. So what I need to do is I need to specify which image am I using. So that's the raster, where I want this information to be stored. So I'll just select that for the image chips where I want them to be stored. What is my training data? So I'll just use the palm training that you saw there. In case we want to identify a class value for each to recognize that, based on the training data I've fed, please consider all these features that meet this criteria for class, then I'll be able to do that. And then I can change some of these variables, parameters. So in the case of metadata format, based on the guidelines here, I can choose what actually works for me. In my case, I can choose labeled tiles, whereby I want each tile to have a label and some information captured on it. Again, on the environment, I can specify the extent of this analysis, which could be defined by many factors, and then the cell size. So this could be maximum of inputs, minimum of inputs, or you can basically specify anything. So for example, if I wanted it to be 0.3 cell size, then I'd be able to specify that. So once that is done, I can run the tool. So let me just clarify that I would have loved to run this tool, but this would end up being like a call for just over 45 minutes. So I will just not run the tool, but I'll show you what the outcome would actually look like. So if I opened, sorry, let me just open this particular folder. So the outcome of that analysis is the image chips folder has some information. So we have the actual images, which basically has cut down the entire image into sizes as specified on my tile size. So this, I think, was left at 256, if I'm not wrong, for each tile, which you can see there. So with these chips also, we have labels. Remember, I had chosen my metadata to be labeled format. So for each label, it's telling me the file name itself and the size, which you can see is 256 by 256. The depth means is that it's taking 3 bands. So this particular image has 3 bands tied to it. And this is the extent of my bounding box over that particular chip. The other information that I get is the accumulated stats, which is statistics, which is a JSON file. But I can also look at this information on my text document here. So you can see that we have 925 images created in total based on the extent that I had specified. And yeah, so that's just the class value that was used for this kind of analysis. So if we had different classes, it will list for each class value how many images or what's the outcome for each particular chip and so on. So we have that as our outputs. So the next step I would like to do after exporting my chips is to train my model. So I will use the train deep learning model tool here, whereby I select my input training data, which you remember, it was our image chips over here. And then I will select where I want my model to be saved. So I would like to select that and just add one because it prefers working with blank folder. Then I can specify how many times I want this particular tool to run to be able to define or to keep on refining the output itself. So if you add the number of epochs, it's going to become closer and closer to your actual results, expected results. If you reduce epochs based on, again, your processing capabilities and any other reason whatsoever, then definitely the accuracy of that may vary. You're also free to update your model parameters and so on. And you can go to the advanced section also to change the backbone model. So the good thing for all our tools is we have our information icon there, which can explain based on what you're interested in, what will be the best backbone model. So in this scenario, for instance, I will use this one, for instance, and again, beyond that for environments, because now this is where the processing capabilities of my workstation is especially needed, then I could switch to GPU and it will just boost the analysis I'm doing based on the processor type that I've selected. Again, once that is done, I just simply run the tool and I will get my outputs. So what that would look like is, let me just open it again. Sorry, I must have lost it somewhere. The outputs that I would get are as follows. So I have my deep learning packages that are in two formats. My model in two formats. So we have a deep learning package, which is shareable also online. Then we have an EMD file, which is an Esri model file that can be used. And then the other outcomes or the outputs I have are my model metrics and other information. So if I opened my model metrics, for instance, after running this tool, then you'd see that based on the 20 epochs I had mentioned, I can't remember how many I had mentioned, and the learning rate that is being applied there based on the backbone, again, of my model, you can see that my training data, every time I kept on running, we're getting closer and closer to the validation, meaning that whenever you do this, you want the blue line to be as close to the orange line or the orange line to be as close to the blue line. If it's a bit too varied, just means you need to keep on refining your parameters to get the output that you will need. So you can see just being able to ground truth and also predict, we can see that that's the kind of output that we are getting. So initially, definitely there's some information I fed and the model has continued to refine and learn to be able to pick even trees where it would not be even possibly as clear to you with your own eyes. So you can imagine this has ran over the entire image and it's giving us the result just there on the fly, which is, I would say, like a very useful output that we could use. So once we've trained the model, finally, we can use the detect objects tool. So we have different tools based on what you're interested in doing. We can do a bit of change detection, just comparing two periods. We can do a bit of, excuse me, we can do a bit of classification. So it's just checking all the different pixels and classifying them based on, for example, land cover and so on. So for us to choose the detect objects, then again, I would specify my raster that I'll be using. Sorry?
Can you hear me?
Yes.
Well, thank you very much for the lovely session. It seems we have some questions here, and I think we have like 5 minutes to just go to the next session. So I don't know if we can take this session. For me, I think it's been a very wow session. I don't know if we have anyone here online or on site that's actually enjoyed the class. So for me, I think the ability for us to be able to use the measuring portal to run predictive analysis is something that is worth exploring for me. So I don't know if you have any questions in now. Any questions for now? Okay, so can we take your question, please? Okay, so I think one very big question here, Pauline, is the fact that everyone is really optimistic. I mean, they would love to lead their hand.
Could you please just I don't know, there seems to be an issue with
Okay, can you
audio.
hear me now? Can you hear me now?
Yes, now we can hear you.
Okay, we can't be taking out the issue. Okay, so I'm seeing one of our participants online, sorry, on site is asking
Mm-hmm.
that lay their hands on the portal. Is it possible that they can have access to the portal in order for them to try out some of these things that you've done? So how can they access the AfricaGeoportal portal? Kind of question, right? Yes.
Just to confirm, I've heard your question. You're asking if how someone has asked how they can access the tools or the models.
So if they can access the portal, the AfricaGeoportal, like is it free to access the AfricaGeoportal? I mean the portal that you're using.
I'm really sorry. Like the audio is really, yeah, I think for most of us online, we're really struggling to hear
Okay,
what's
so
going on in the room.
can we confirm if other persons online can hear me? So maybe can you hear me clearly now? Can you hear me clearly? We can't hear you. Okay. Any other person? Can you hear me? How about now? Okay, so I think we're going to put the questions together and just share with you. For me, so let's appreciate for me for joining this session and for the wonderful work that Pauline. We're going to put the questions together. Pending we were able to resolve this question together, then we will share with you. Yes, I think Ola did that activity for us. So we would love to know how to access the portal. So we will get access to that and we'll put the questions together and share with you. So Pauline, thank you very much. Uh, Thank you very much for joining this session. Okay, so let's confirm. People online, can you hear me? So maybe without the mic, it can be better. Can people
Yes.
online hear me? Okay, so I think maybe I'll just use my voice. People on site, can you hear me? So I think I'm audible enough for now. So thank you very much, Pauline, for joining the session, for taking this class. It's been a very impactful and very interesting class for us. So thank you very much. We're going to put all the questions together, but if you can hear me as a last stop, I think one of the major things that was asked is how can they access this portal? So I think additional questions in line with that, we can put them together and share with you. Okay, thank you very much. I think she just put it up there. So for you to be able to access that. So I'm sure we'll communicate this to our participants and we can then go ahead and just take this up and probably share further questions with you. Can we appreciate Pauline once again, please? Thank you very much, Pauline, for